if I say to a Computerphile audience network, probably their mind's going to go to Wi-Fi and Ethernet or whatever. But there's another way to interpret network. What a mathematician would call a graph, just anything that's connected. So we can visualize loads of things as networks. The connection between people who talk to each other, people who are friends, is a network. If we ask about everybody who's ever made videos on the same YouTube channel, we could construct that as a network, you know, so I'm now connected to all your other contributors. This is where a lot of my research is these days, and I want to talk specifically about the idea of temporal networks, where we've got a connection, and the connection happens at a particular time. Let's give a specific example. Let's imagine we're thinking into the murky world of cryptocurrency, right? And a lot of people are immediately going, oh, it's a scam, Richard, don't, right? All right, but maybe the interesting question is, it's what type of scam? Maybe that's the interesting question. So let's think about this as a network. How do we form this into a network? So let's imagine this represents wallet one. So this is somebody with a wallet on a crypto network. This is somebody else with a wallet. This is somebody else with, so they've got a certain amount of money. Why do we always draw dollars when we're in the UK, eh?
It's just easier, I think, that people understand all around the
Really,
world.
if I drew a pound sign, it's going to look a bit wonky. So these people are sending some money about the network. So here, and I'm going to send them like $10, and I'm going to send that at 9 a.m. I'm going to send them $10. I'm going to send that at 10 a.m. Now, let's imagine now this crypto networks can have a little bit of fraud on them, maybe. Let's imagine this person, a little bit dishonest, they've stolen some money. They also send $10, just to keep the example easy, but they've sent it at 9:30 a.m. So now we've got a network. We can think of this, we can abstract this as some nodes and some links. So a node and a link here, and the links are annotated with time. Why is that useful? If we want to ask the question, so this person has stolen this money, we want to ask, where's this stolen money gone? It was sent at 9:30. It can't have gone this way because this link's at 9. It's a very, very obvious observation. The money has not gone in this direction. It's definitely gone in this direction. But if we don't put time into the network, we can't really follow that. We can't follow the path through the network. And people do take pains to hide these things, so they do make a lot of, like the shell game you see here in London on like London bridges. You'll see somebody with 3 cups and a ball under it. They'll move the money back, try and disguise it. But you can only follow it through these time-respecting paths. That's one of the reasons we like to study the temporal networks. I'm going to talk very briefly. I'm going to give you a motivating example. So you have got a video that covers this a little bit, but it's really important. So it is worth going through again. Do you recall something called PageRank, maybe? I'm putting you on the spot because that was a long time ago.
I do remember PageRank. Is it about how Google used to choose what went to the top of the search?
Yeah, very, very good, yeah. It ranks pages. Although weirdly, it's named after Larry Page.
Oh yeah, one of the founders of Google, yes. That's
Mathematically, we study it as a Markov chain. I try and motivate my students by saying Larry Page is a multi-billionaire because he paid attention when somebody was teaching him Markov chains while I'm teaching Markov chains.
Please carry on listening.
Please listen. So, I'm going to briefly show you, just recall PageRank, a little bit more detail. Then we're going to go and look at some software that deals with temporal networks. The software is called Raphtory, Raphtory, And it was created by a PhD student of mine several years ago. It's become pretty successful now, so I really love this bit of software. It's great for doing stuff with temporal graphs. I'm not on the payroll, but it's something that I use in almost all of my research. So let's have a look at this PageRank and see how it works, and then we'll go over to the computer and see it in action. The task we have is, how do we find the most important web page? Because old school search engines were real bad.
Well, it was a list, wasn't it, really? It was kind of...
It was a list, but it wasn't particularly in any order, right? So you'd say, oh, give me a web page about computers, and it would go, right, here's 50 web pages about computers. And, you know, some of them would be real, like, okay, that is 50 web pages about computers, but look at the state of them. We need some way to say what's important. So let's imagine we've Google, we're trying to search for, something. We want to put them in order. Let's imagine you, me, and Dr. Mike, we've all got web pages, so...
MySpace or something, yeah.
MySpace, is that still a thing? I don't... So let's imagine, there we are. We've all got our little web pages. Now, I'm only an academic, I'm not getting a million hits to my web page. But let's imagine I link to your web page because we chat and we sometimes go to the pub and what have you. And you link back to my web page, and you link to Mike's web page, Mike link back to yours, and maybe I link to Mike's, but actually I've never met Mike, so maybe he doesn't link back to mine. And that forms a network. We've got a network or a graph structure. Now, name me a celebrity.
The Rock. What about The Rock?
The Rock. Oh, right, brilliant. Yeah. Obviously, he's writing his own webpage. Let's imagine we've got The Rock. Now, yeah, so he's working on his HTML, pops it up. He goes, obviously, I'm got a link to... He's got a link to Mike, right? He's a big fan of Computerphile. He links to Mike's, but he's got a million links incoming. So there's a big cloud of things here. Maybe I've linked out to one of those. So now when we decide who's the most important, we can say, okay, The Rock is real important because he's got loads and loads of links. But Mike got a link from The Rock. So that's going to make him pretty important, right? Because this high profile has linked to him. So here's the model that PageRank uses. It's kind of a random clicks model. I should actually say, these are all the pages about a certain... Now, I've painted myself into a corner. These are all the pages about a certain topic. We're all fans of Computerphile, and The Rock watches Computerphile all the time. It's like, so, these are all people who list Computerphile, and The Rock, he doesn't like to talk about it too much in public, but he watches Computerphile all the time, I happen to know. So these are the web pages about Computerphile. So now we want to decide what's important, and we use this random clicking model. So we assume that we're just kind of, it's not doom scrolling, but we're just idly browsing the web, looking for people who are on our list of Computerphile websites. Right? So we start off at Mike's maybe, and actually I've only drawn, so let's draw another link on here. So we go to Mike's, and he's got 2 links on his web page. We'll just flip a coin, choose at random. So we choose to go that way to yours. And again, random clicking. So we're just clicking with our mouse, following the links on the website. Flip a coin. You link to me, you link back to Mike. So we're going to go to me. I've got 3 links, so there's a 1/3 probability, 1/3 probability, 1/3 probability. So I'll go back to Mike, maybe. And we keep following this process of randomly flipping coins. And then we ask the question, if we follow that process, how much time do we spend on each? And what proportion of the time do we spend on Mike's, Sean's, mine, or The Rock's website about Computerphile? And if you've got loads of links in, you're going to get more time. But if your link is from somebody with loads of links, you're also going to get loads more links. Mathematically, we can form that up as a
like a ratio thing, isn't it?
Yeah, it's like a ratio of the time we would spend if we follow this random clicks process. So we can formally say that I've drawn 3 links from the Richard web page. So 1/3 of the time I go to Sean, 1/3 of the time I go to Mike, and 1/3 of the time I go to whatever this one is over here. And we can mathematically follow that, formulate it as a Markov chain and solve that. And we're going to get something like, oh, the Rock scores 0.3 and Mike scores 0.2 and me and you only score 0.1 and everybody else on here gets some little score. So he's like, well, more important, but Mike's quite important because we've got that link, and we're a bit less important because we've not got the link, we've not got that major celebrity endorsement we're looking for.
It'll happen.
It will happen one day.
I think
One day the Rock
Taylor
will...
Swift's probably watching this now.
Exactly. Okay, so I haven't made that algorithm terribly formal, but this is the essence of it. There's some little tweaks, like what if you get stuck in a dead end, but nah. So what we're going to do now is look at this and ask, when is something most important? And I'll show you how to do that, but we've chopped the network up into time. So let's get over to the computer and we'll take a look. Okay, so we've talked about the PageRank algorithm, but that wasn't temporal when we did it there. It wasn't changing in time. So now I'm going to take an example network, and the example network we've chosen here is actually, it's quite a cute one. It's the network of Lord of the Rings. Now, I think the project this comes out of is called One Network to Rule Them All. That's a great title, isn't it? Lovely. So what they've done is they've done some natural language and processing on the text of all the volumes of Lord of the Rings. I'm going to say something wrong about Lord of the Rings at some point in this video because I haven't read it in 25 years and I've not even seen all the films. But these people have done natural language processing on Lord of the Rings, and every sentence where people appear together, we count that as a link. Now, what about time? We're going to say the time is the order in which that's happened, right? So for people who don't know the story, they're a group of people on this epic quest, and they meet up and they split apart. And this happens multiple times. So like in this particular sentence, the hobbits have met the elves because it was the early days. The hobbits learned their letters. And here's Bilbo and Gandalf together in a sentence. And it says Bilbo meets Gandalf, and that's on sentence 13. Now, in some of these cases, meets, there's a little bit, they're not really, because we're actually, I think we're in the introduction of the book here. They're not actually meeting, they just happen to be in the same sentence. But if we go on later, Frodo stripped the blankets from Pippin and rolled him over. So Frodo and Pippin are clearly together right there. So we're going to do PageRank to see who's important in Lord of the Rings, right? So who's the champion, right? Who's the most important Lord of the Rings character? In terms of their social connections, right? Their fame. Who's the most famous Lord of the Rings person? Is it plucky young Samwise? Is it Gandalf? Whatever. So here's my terrible Python code. I'm sure there's better ways of doing this. But we've got our text file here. It's got a bunch of things in it. But the main things I'm interested in are this column 2 and column 3, and that's the character and the character they're meeting. We're just going to read that as a CSV, comma-separated values file. So I'm using the pandas library, which pretty much everybody who uses Python is using. But we're also Raphtory, this code that my PhD student originated. Open source, so please do have a fiddle with it. It is so useful for this kind of thing. And we're going to import that as RP, and we're just going to do the PageRank algorithm on the whole graph, just everything, right? So shove that out there, shove the whole graph through, but then we're going to do some other playing. So we're going to get the top 5, who's our best 5 Lords of the Ringsers, and we're going to focus on Gandalf and Frodo. But then we're going to do something a bit more clever. We're going to use this concept of time, or in this case, it's not precisely like a clock time. We're using where...
Ordering.
Ordering, yeah. which is a form of time. So I'm going to pretend the order that I meet up is a time, and I'm going to use the Raphtory software to split this up into a window. So here's our, just getting the PageRank, it'll call the Raphtory standard PageRank algorithm. But here now, we're setting up a list for Gandalf importance and Frodo importance, and we're going to take this graph and push it through a rolling window every 250 meetings, right? So we're chopping the book up into 250 meeting cycles. We're going to ask how Frodo and Gandalf evolve through the book. And this is just some matplotlib gubbins to plot it all out. So we're going to give a marker and a legend and what have you. So let's just run that code. Legendarily, when I press run on these, they normally break. But let's see how we're doing. So we've loaded in the graph, and we can see, so this is our PageRank algorithm, and it's telling us, initially it's telling us Gandalf ranks as 0.04, Frodo ranks as 0.06. Here's our top 5 Lord of the Ringers. So I don't know whether to announce it top of the pop style, really. Coming in at number 5 is Gimli. A little unexpected, actually, for me, that Gimli.
Well, he's in it, and he meets all the people, doesn't he, I suppose?
He does, he's hanging about. Is he the one who has you have my axe?
Yes, yeah. Very dangerous across short distances.
That's right, yeah, you throw him across the chasm at Helm's Deep. So, moving to number 4, Gandalf. 3, Pippin. Aragorn at number 2, Strider, the heroic ranger. But at number 1, probably not unexpectedly, Frodo. But, so this is the bit that I really like. We can look at it over time.
Because there's huge chapters about various different characters.
All right, so look at this. At the start of the book, Gandalf's kind of there, but he's just doing some firework displays. They're messing around in the Shire. Then Gandalf, for some reason, has a little holiday, and he's not in it. You remember? And there, all the hobbits are running about, hiding from the ring wraiths. It's tremendously exciting. They're going towards...
Going to Rivendell.
Rivendell, thank you. They're going to Rivendell. So Frodo and all his super team are hiding out. It's all Frodo all the time.
Meeting lots of people.
Meeting Tom Bombadil and all of that good team. So early on in the book, lots of Frodo. Not quite so much Gandalf. He comes in, he shows up a little bit. Now, then, Balrog doesn't go so well for Gandalf, right?
Yeah, spoiler.
Oh, God, yeah, spoiler alert.
You shall not pass!
Spoiler alert, fly you fools, etc., all of that. So, Gandalf, then, a little bit of decline in importance. Then, heroic Gandalf the White comes back, has a fight with Peter Cushing. Is it Peter Cushing?
Saruman, yeah.
Yeah, Saruman, yes. So then, a lot of Gandalf in there. And now, Gandalf actually, in the later bit of the book, if we think about it in terms of what PageRank is doing, it's all about how you meet. So, I hated this bit as a child, because Frodo and Sam are just wading through a swamp for a long, long time. They're not meeting anybody apart from...
Dead marshes. Yeah.
Right, it's right, the dead marshes, right. So now, if you think about their PageRank, they've not got a link to The Rock or Taylor Swift or whatever. They've got a link to Gollum, and Gollum is not important. So, Frodo is sunk in the charts by the later stage of the book.
Yeah.
Gandalf's like way ahead because he's off. Is he at Helm's Deep? Can we remember?
Yeah, he goes off to help the Rohirrim, the Rohan. Yeah,
he's back, flashing his staff about, doing all that good stuff. So Gandalf's, later in the book, Gandalf's actually well ahead of Frodo on those PageRank algorithm. He's getting to the top of the Google searches there. But then back to the end, and I've got to do the scouring of the Shire, and so Frodo's like popped ahead, and he's meeting all the people again, and he's back at the beginning. And that's the kind of thing you can see when you're treating these graphs as temporal graphs. There's one last thing I'd like to show you, because I want to show this software. I'm so proud of, not my achievement, Ben Steer's achievement.
Oh, is it visualizing it?
Yeah, so it's a nice little visualizer, so we can zoom in and pull out the various people and see who they link to. So here's Elrond, your like elf chief or whatever he is, and there's Balin, and we can pull out those nodes and see the connected. Oh, Balin's not meeting Elrond, but here's Frodo.
I'll tell you what that reminds me of. A few years ago on Numberphile, they did a video on game books, and they took one of these choose your own style game books and they turned it into a node graph.
Oh yeah. So that's perfect for this kind of graph thing, and it is time ordered because you can only go through that in a certain way. Let's see if there's any surprises if we go further down. So if I ask for the bottom people, it will be people who you don't even remember. Whoops.
Like Guard B.
Exactly.
Orc C.
So get the top 50, and we'll look down and see if there's any surprises. So here's our top 50. So look, this is a toy fun example, but we can use this for serious research. Like, if we're thinking about those crypto networks, we could ask the question, is there a sudden spike in popularity that makes us think something is suspicious? Oh, right, suddenly this person who was doing nothing has now become top of the pops and is the most important person on earth. Why is that? Or maybe if we're thinking about the old NFTs, which aren't so popular anymore, when we looked at those, we could see them being traded round and round in circles because people were swapping them between each other in a little gang, pumping up the price, and then dumping them later when they'd traded them between themselves enough. So while the Lord of the Rings example is not the most serious thing I might have chosen, actually this can be used for some real important stuff like finding fraud, looking into social networks, looking into how people interact on social media. Loads and loads of examples. Use your information. So this software, Raphtory, it's really great for looking into any network where the thing changed in time, and that's what you're interested in. We've proved ourselves the world's worst people to discuss celebrities, I think, today.
Absolutely.
Because it's not... I got the wrong person the first.
Oh, it's Christopher Lee, yes, not Peter Cushing. And I think earlier,
you can see why I muddle them. They're always fighting in films,
Absolutely.
but no, right, okay, yes.
I think earlier I said Taylor Smith.
Taylor Smith, yeah.
That very famous singer.
We've not got our fingers on the pulse of pop culture today, have we? Not quite.